These are the notes for LT2 within the energy unit. Your task is to be able to calculate the rate at which energy is used. And that rate at which energy is used is called power. If you're in class, you know that we started talking about it in this context. Just looking at the formulas should tell us the difference between work and power. Okay, there's only one difference there. They both take into account a force. They both take into account the distance. But power cares about how fast, all right? How fast you can do work. And that's really the only difference. A lot of people, when you hear the word power, you think horsepower. And on howstuffworks.com, there's a great article that, again, if you're in class, you know we went over it, about how horsepower works and where we came up with this idea of horsepower. All right? And James Watt was the inventor of it, which should make sense once we talk about some of the calculations here. But when you hear the word watt, most people think about light bulbs, but it's really just the unit of measurement for power. And what he did is he looked at like what's the average amount of work a horse can do in a certain amount of time. And it wasn't all that scientific, but that's how we first came up with this idea of a horsepower. So if you see it is 33,000 foot-pounds per minute, it means that somebody could lift 33,000 pounds, 1 foot, in 1 minute. That's 1 horsepower. I don't know of a human that's going to do that. So on average, like a human is 0.1 horsepower. It's kind of the amount of power that we can sustain. But I encourage you to take a look at this article. Again, it's howstuffworks.com, because especially if you're into the whole muscle car thing, they talk about the horsepower of some of those. And its power to weight ratio apparently is a big deal, because the higher that is, kind of the more get up that these cars have. So that's just kind of for your own entertainment table there. All right. So first thing, the word rate. Okay, the word rate within the target. I can calculate the rate at which energy is used. One of the most common rates that we have, that maybe you've heard something rate, is a heartbeat. Okay, it's our heart rate. But any type of a rate is how often something happens, and then how often per unit of time. So if you look at your heart rate right now, okay, maybe it's 90 beats, and that's in 1 minute. Okay, that could be a heart rate, for example. Okay, so there's lots of rates out there. Power. Okay, on your formula sheet, you're going to see power in 2 different forms. It's work divided by time, which is pretty self-explanatory. But it's also force multiplied by the distance divided by time. It just depends in the problem how it's presented to you. If the work is already done, you know, you get something has a work of 10,000 joules, then you go here. But sometimes you'll have to calculate the work first. So they'll give you a force, they'll give you a distance, and then you divide it by time. All right, so there's not much difference there. It's kind of the same idea. So we know that this is the rate at which work is done. Okay, the rate at which work is done. And so it could be work divided by time, or force times distance divided by time. Those are the same thing. Okay, those are the same thing. Beyond that, okay, really beyond this, is the idea of our practice problems. Okay, our practice problems, LT2, calculating power, and we'll put 1 or 2 in the notes here. The number 1 says, how many watts of power are needed when a force of 10 newtons? Okay, 10 newtons, there we've got a force. Moves an object 8 meters. Now we've got a distance, 1.75 seconds. Now we've got a time. All right, so we're looking for the watts of power. So we know that power is the force times distance divided by time, which is going to be, in this case, 10 newtons times 8 meters divided by 1.75 seconds. And there's my calculator. So we're going to go 10 multiplied by 8. That's not 10, how about that? So 10 multiplied by 8 divided by 1.75. We're going to round to the 10th. So it's going to be 45.7 because this one says we do not round the 7 up. So 45.7 what? Watts. Remember, James Watt was the guy that figured out what 1 horsepower was. And so because he figured all this good stuff out, he named the unit after himself. All right, so 45.7 watts. I'm actually going to skip to number 5 on here, because this is the slightly different format where it says if you do 2,000 joules of work on an object in 2 seconds, what is your power output? Well, this is already in work, and this is time, because joules is a unit for work. So, not any more difficult, maybe a wee bit easier. Power is work divided by time. So it's going to be 2,000 joules divided by 2 seconds. So 1,000 watts. All right, 1,000 watts. All right, now the trend here, okay, other than just flat out plug and chug, is are we understanding this rate idea? Okay, because we want to think about what would be more powerful. Okay, if you and I can do the same amount of work, if we can both do 1,000 joules of work, but let's say that you can do it in less time. If you divide by a smaller number, you get a bigger answer. Okay, so think about that. We both do 1,000 joules of work, but you can do it faster. So a lesser amount of time to do the same amount of work, that gives you a bigger answer because you are more powerful. If we can both bench press 100 pounds, but I'm grunting and groaning and having a heck of a time getting it up off my chest, and you just rip that thing off, man. You're just no problem. Okay? That means that you are more powerful because it takes you less time to get that bar up and down. All right, if we have the same amount of weight, same force there. So number 3 is more of a thinking thing. It says you expend 200 watts of power to do 2 pull-ups in 3 seconds. Okay, how much power do you expend if you do the same amount in either 6 seconds or 1.5 seconds? All right. This 2 pull-ups is there just for a reference. I'm just telling you the exercise. Okay, we're both going to do 2 pull-ups. That's all. All right, so who cares? Ignore that number. 200 watts of power, 3 seconds. Now, if it took the same person or a different person, whatever, 6 seconds, we need to compare our times. Okay, our first step is to compare time. So think about it as 6 seconds versus 3 seconds. It takes this person 2 times longer to do the same amount of work. If it takes you 2 times as long to do the same amount of work, just common sense, you are not as powerful. You don't have the power. If it takes a car twice as long to get up to 60 miles an hour, that car, I think most would say, oh, it has half the power, right? That's all you do here. So once it's 2 times longer and it's less powerful, then we just go with that original power, 200 watts, cut it in half. So this person only expended 100 watts of power because it took them twice as long to do the same amount of work. Now down here, all right, so 200 watts in 3 seconds. That's our reference. Well, what if somebody could do it in half the time? What if somebody could do the bench press in half the time, or could run the meters, 100 meters, twice as fast as you? Something like that. Well, compare our times. So 3 seconds versus 1.5 seconds. Okay, that is 2 times now, 2 times shorter equals more power. So this time, instead of dividing by 2, we still have that original 200 watts, but now we're going to multiply it by 2. So this person could expend 400 watts. Okay, we've got to get that trend going. All right, where we compare times, and then if it's less time, we're more powerful. If it takes them longer, a greater time, then they're less powerful. So one more here. 500 watts to sprint 100 meters in 12 seconds. What if you run the 100 meters in? Okay, the 100 meters, I know there's a number there. You don't do anything with it. I'm just showing that you're going the same distance. So 36 seconds. So we compare our times first. 36 seconds divided by 12 seconds. That's our original time. Means it took them 3 times longer. If it takes you longer, you are less powerful. So we take that original power, which is 500, and we divide it by 3. Okay, so we're going to go 500 divided by 3. We get 166.7. So this person was only able to expend 166.7 watts because it took them so much longer to run that 100 meters. But this next person, we compare our times, 12 seconds versus 6 seconds. That is 2 times faster, shorter, okay? Which means they are more powerful now. So we take the original power, which is 500, and we multiply it by 2. So this person, 1,000 watts, because they took that 100 meters and man, they moved. They achieved that in 6 seconds versus 12. Half the time, twice as powerful. And that is it for LT2. Good luck.